Hi again. Today we're going through factorizing again. So factorized completely x to the power 4 minus y to the power 4. So I'm gonna have here a little reminder from the previous session. So if we have a squared minus b squared, it can be written as a minus b, a plus b. So what do we think here? So is x to the power 4 can be written as a square. Yes, indeed, we can. Um, so x to the power 4 minus y to the power 4. What applies to x to the power 4 applies to y to the power 4, obviously, because they're just, letters here and there. So we can write this as a square, indeed. So can we do for this one? Okay. So I can identify my a as x squared and my b as y squared. And I'll apply this reminder with formulae that I've just provided you with. And we're going to get x squared minus y squared, x squared plus y squared. Okay, so as I told you previously, we can only use this formula when there's a difference, the difference of square formula. So this one will remain as it is, but this one we can use it again on another scale. But on a scale where A is x and B is y. So x minus y, x plus y. So this translates onto this, and this remains the same. Can we factorize it any more than this? The answer is no. And we're done with this one. So let's move on to the next question. This one, I'm gonna write it first, then we can work on it. We have, do we have a common factor between all of these terms before we work on it? Yes, we do, which is x. And 6x squared, but it becomes, and this is becomes 7x minus 5. So what is this? This is a quadratic expression, and we've gone very in detail in the previous video about how to factorize quadratic expressions. If you're still struggling with it, please check that out. X 6x squared. So I'm gonna identify my a and b and c. So we know that a quadratic expression is an expression written in this form. Okay, plus c. So my a in this case is 6, my b is 7, and my c is minus 5. A times c, the product of a times c is minus 30. Okay, so we know to find the factors, like we use these two facts, we need to find two numbers that multiply and gives you minus 30. And when you add them together, it gives you 7. I can think of two that multiplying gives you 30, minus 2 times 15. And what else? We have minus 6 times 5. Do we have any more? Minus 10 times 3. So, which one of these to add up to 7? So 15 minus 2, no, it gives you 13. Neither if you do 2 times minus 15, gives you minus 13. 6 minus 5 or 5 minus 6, it gives you 1 or minus 1. So my suspect is minus 10 times 3. So minus 10 plus 3 is minus 7. So I would use 10 times minus 3 instead to divide this 7x. So it's the same thing as saying 10x minus 3x. And as I always said, you might get it on the first try. It took me 2 tries to get to the right answer, but it's fine as long as you get there. So I'm just here to show you that you might have to go through a couple of them, but always think of it like it's something you will do automatically later on once you get more experience with these. You don't have to write it out like this, but I'm just writing it just to make it make sense for everyone. Um, 10x minus 3x minus 5. So this is the same thing. I just split 7x into this, but we can't do the split randomly. We do it through this method. So eventually we'll get factors which we will get in soon, basically. Um, so I'd rather have 6x squared factorized together and this one 10x minus 5 together because they seem to share factors um better, I would say. So 3x is a common factor between this one and that one, and we'll remain with 2x. 3x times 2x is 6x squared, and minus 1. To retrieve the minus 3x, we just add minus 1 here. And for the second one, for these two, is plus 5 and 5, 2x minus 1. See? Finally, we've got this. I'm gonna take this away. And now we've gotten 2x minus 1, so it's x times 2x minus 1, then 3x plus 5 times 3x plus 5. Because they share this common factor, we're allowed to do this thing. Okay, can we factorize this anymore? The answer is no, so we're done. Because it says completely, so we always have to check at the end. Now we've got the challenge where we've got to write the following expression as a product of four linear factors. So, some of you might know how to do this, but if you've never come across through these kind of questions, it might be tricky, but it's very simple. We're gonna use one simple tip, which is this actually reminds you of like a quadratic expression. The only thing is instead of having x here, yeah, you have x squared, and instead of having x squared here, you've got x to the power 4. So what I'm gonna use, my tip is that I'm gonna substitute, you know, x squared by x. That means, in other words, I'm gonna say that's x. I'm gonna let x equal to x squared, and I'm gonna replace it in the expression, and I'm gonna end up with a quadratic expression, if that makes sense. So basically, I'm going from here to here by substituting, but when I'm done, I'd have to go from here to there because my question is in terms of x squared, not in terms of big X, okay? So you're doing the substitution just like to work around the question, and once you're done, you turn it into the original form. So okay, so this becomes 4x squared because x squared is x to the power 4. If this is this, then x squared is gonna be x to the power 4. Does it make sense here? I think it does. Okay, so minus 13x plus 9. So this is my expression, my new one. So how can we factorize this? We're gonna do it the simple way, like we've done so far. So my a is 4, my b is minus 13, my c is 9, a times c is 36. So I'm focused on these two. So we need to find two numbers where a times c, which is 4 times 9, is 36. And two numbers, when you add them together, it gives you minus 13. So I can think of 4 times 9. 4 times 9, when you add them together, it gives you 13. But because b is equal to minus 13, so what we'll be adding together is here times 9. What we'll be adding together is minus 4 times minus 9. Okay, so this is what we'll be adding together. So 4x squared minus 4x minus 9x. Again, what I did, I only splitted it in an efficient way to facilitate factorization. Um, so here 4x is x minus 1, because 4x is the highest common factor. And then 4x times x is 4x squared. 4x times minus 1 is minus 4x. Then here, minus 9 is the highest common factor, x minus 1. You see, minus x minus times minus 1 is plus 9. So being x appearing here and there, then it's a common factor among these two, and we can write 4x minus 9. Am I done here? I'm done with the initial factorization, but as I said earlier, because the question is in terms of small x, we always have to turn back to the original. So I'm gonna substitute my big X with x squared, because that's why I assumed that big X is equal to small x squared. So I'm gonna substitute back onto my original expression, and we'll see. If it needs more factorization, then we will do that. Okay, as I can see, clearly we need to factorize it one further step, and I'll just remind you of this special formula which we used earlier. A squared minus b squared is equal a minus b times a plus b. Can we use it here? The answer is yes. And can we use it for both? The answer as well is yes. So in this case, my a is x and my b is 1, because 1 squared is 1. So I'm gonna write this as, oh sorry, x minus 1, x plus 1. And the second one, I'll just show you here. I don't want to write a whole line. So this is 2x squared minus 3 squared, okay? So I can write it as 2x minus 3, right? 2x plus 3. As I said, a and b could be anything. It literally can be a potato, as long as it's a square. 2x minus 3, 2x plus 3. And indeed, did find a product of 4 linear factors, which is x minus 1, x plus 1, 2x minus 3, and 2x plus 3. And if you come across this question, please use this tip, otherwise you will, you wouldn't get so far. And thank you everyone for following through till the end of this lesson, and I shall see you in the next one. Bye.